Hi guys, welcome back. Section 3.2, part 2. We're now going to shift from graphing them to talking about the transformations just by looking at the graph. This should have some sort of function name to it, so we'll just call it g of x here. Alright, so when we're looking at f of x and we're trying to come up with our transformations, remember for exponentials, if it occurs in the exponent, we're going to do the opposite of what it says. It's a horizontal transformation. If it's outside of the exponent, then it is a vertical transformation, and we do exactly what it says. So this negative sign here, well, let's start with our horizontal stuff. So here up in the exponent, I've got x minus 2. We're going to do the opposite of what it says. So this is a horizontal shift, not left, but right 2. All right, and then shifting now, shifting. Outside of the exponent, I've got a negative in the front. That's going to be a reflection across the x-axis. So remember, if you're changing your y values from positive to negative, you're going to go across the x-axis. The 2 out front is a vertical stretch by 2. And the 3 in the back is a vertical shift. It's positive, so we're going to go up 3. All right, for B, for our logarithms, if it's inside the log, that's your horizontal transformations. You do the opposite of what it says. If it's outside of the log, it's a vertical transformation, and we do exactly what it says. This base here does not affect anything. That's just saying your parent function. It's kind of like the base of your exponent doesn't do anything. The e doesn't matter. What matters is the stuff in the exponent in front and behind it. What matters here is what's in the argument and what's in front and behind it. The e and the 5 here just tells you the function that you want to transform is e to the x. Or the graph that you want to transform here is log base 5 of x. That's the one that we're shifting around. All right, so for log base 5 of x minus 5, this x minus 5 means we're going to have a horizontal shift. Not to the left like it says, but to the right 5. All right, the 3 out front is a vertical stretch by 3. And the 4 in the back is a vertical shift up 4. All right, looking at the U-tries for A, I'm just going to verbally say them. So up in my exponents, I've got negative times x plus 3. So that plus 3 means I've got a horizontal shift to the left 3. The negative out in front of it is going to be a reflection. This time they're a reflection because it's in the exponent. The reflection is going to be across the y-axis. I've got a vertical stretch by 4 and a vertical shift down 1. For B, don't forget, A was nice. It already factored out that negative sign for us. But if not, if you've got something that's in front of the x, you've got to factor that guy out before you can start telling your transformations, because it'll affect your transformation. So if I pull the 2 out, I've got x left over, and then 4 divided by 2 would be 2. So notice for this one, instead of being a shift to the left 4, it's going to be a shift to the left 2. So horizontal shift to the left 2. That 2 inside there, instead of multiplying by 2, we're going to divide by 2. So I've got a horizontal compression by 2. And now we're outside of the log, so I've got a negative sign. That's a reflection across the x-axis. The 3 out front is a vertical stretch by 3. And the 6 in the back is a vertical shift up 6. All right, and moving on to example number 3. It says use the parent function f of x is equal to log x to find the equation of the function in the graph. So if I look at the blue graph and the red graph and here, I think j of x looks like a reflection across the x-axis. So j of x is just going to be log x, but with a reflection out front because it's across the x-axis. Oh, no, that's not right, Miss Harris. That's not across the x-axis, is it, Miss Harris? No, that's across the y-axis. And so if we have a change in y caused by a horizontal shift or horizontal transformation, so that negative sign needs to be inside. If you want to check yourself, it's a test, and say you forgot, does the x go on the outside or on the inside? What would you do? Don't forget that calculator in front of you. Graph both negative log x and log of negative x and see which one looks right. All right, for f of x, my basic graph, which is the blue graph, is log x. But it looks like this graph, if you choose the point here and find its corresponding point, it looks like it got shifted to the left, 1, 2, 3, 4. So it's going to be not x minus 4, the opposite for your horizontal transformation, so x plus 4. And then down 1, 2, 3, so minus 3. And we talked a little bit in class. Some said, oh, well, it looks like it's been compressed. And some said, no, I don't see it. If you zoom in to just this portion of the graph, and just ignore that big long arm that's out here. If you look at this box and this box, you'll see that they look pretty much dead on. So I don't think there's a stretch for this one. All right, there you go. Those are the notes for section 3.2. And I should have time to make at least one video for section 3.3 coming right up.